Monaco. No.
Yeah.
And there you go. We're hitting up our 5th lecture video homework notes.
Yep.
We're hitting up classification of matter, particle diagram.
Yeah, this is cool. And then there's a cool pogle, first pogle that goes along with this.
I think my students may have already finished that, but this will be reinforcement for you, so it's a good thing.
And my students are all over the place. They are just running.
Doing well.
Yeah, they're running all over the place.
In a good way.
Yeah. Running, I can handle it. All right, first section here. Oh, wait. What do you think is going to happen first?
It says learning target.
Yes, we're starting to figure this out.
So what can you do?
After watching this video, you shall
classify types of matter as elements, compounds, mixtures, and be able to draw particle diagrams of them.
Facts.
Right?
Mm-hmm.
There you go.
And you don't need to be an artist to do this, by the way.
No.
Hey, ready?
You know,
Sure.
what kind of elements we got over here?
All right. The first ones are monatomic or atoms. And-
Mono meaning one.
Right. Yes. All by themselves.
Yep.
And the second box, those are called diatomic molecules.
Yep. Or
So
diatomic elements.
right. So they're two together, but they're the same thing. So they're still elements.
Mm-hmm.
No.
How do we
compounds.
remember they're two if we forget?
Di means two. It's convenient
Mono.
that way.
Mono, di.
And we will later learn the seven diatomic elements.
Yes, there are only 7.
Yes.
Let's hit up some mixtures. Mixtures,
This whole row is
so
mixtures.
pretty, all the pretty colors.
You like pretty colors.
When you see pretty colors, different dots, different particles, you know that you have more than one type of substance in
Yes.
play.
There you go.
Could be compounds, could be elements, could be atoms, okay?
Right, so notice the little lines going out from the word atoms here. All the single spheres are atoms.
And all the double spheres, diatomic molecules or diatomic elements.
Yep.
And then there's the other ones over here that kind of look like Mickey Minnie Mouse. That's a compound, and I know this because there's 2 different colors
Yeah.
of atoms that are actually physically kind of connected in the picture.
Yeah, so pay attention to this real quick in the video where that comes out in color, because your black and white picture in front of you doesn't necessarily, you can't tell the difference in color, right? The
Maybe-
shading, but the size is a giveaway.
This is a great opportunity for you to actually get some colored pencils or markers or whatever and colorize your notes. We put a lot of color in these that don't come out in your packets, and color will help some of you click.
Right. In the resiliency, ready? If you don't have colored pencils, you can take just that big, large green atom and color that in with your pen, and that'll look different than the little ones. So there's always a way. Just because you don't have colored pencils or you don't have markers doesn't mean you can't still differentiate.
Here's an old adage for you: where there's a will, there's a way.
Yep.
If you have the will to colorize, you'll figure it out.
Yeah, academic resiliency. All right, third line. Here we go.
All right, the last one is showing us compounds. So more than one element there, bonded together. It's the same way all throughout. 2 pink and 1 green.
So that makes the whole compound
Pure.
because they're all the same.
Yep.
And what about over here?
Got a heterogeneous mixture. I would really call the first one homogeneous. Looks kind of similar throughout, but
Purples and reds, different elements. You can see that they're different, which is why we went with hetero.
fair enough. We're getting
That's
a really close-up look here.
Yeah, exactly.
Yeah.
And that's the other thing. Like, if this was a real sample of matter, you probably wouldn't be able to tell it was heterogeneous mixture.
Yeah.
That's very difficult to actually see.
And we're not going to do a
mixtures in
Tyndall
class.
test right now. We'll get to that way later.
That's right.
Anyways, particulate nature of matter. When we start drawing these things, notice in the boxes that are here, there's spaces in between. So the spaces have to be represented. And then the actual matter has to be represented because that's the whole kit and caboodle, if you will. So we need both the particles and the space in between them so we can understand. And if we start thinking about phases, which we didn't talk about in the video much, but comes up in the pogle, right? Solids, the pieces are all touching. So there's less space in between.
Making them more dense.
Right. And in gas, you're going to want to draw them separate and not touching. Makes sense?
Just a note on the particulate nature of matter is if you can think of atoms as spheres that can move and be manipulated in your mind, like just very simple, like, just abstraction, right? You're already halfway to understanding what any chemist does when they're thinking of matter at the atomic level.
Right, and there's pictures of it literally right there to help you think
How
of it
are
that
these
way.
particles behaving? So we just imagine a little particle diagram in our head. We apply the rules that we've learned from the facts of chemistry, and we can make a prediction about what's happening in an observation, which means that we're making inferences based on the particulate
Yeah,
nature.
science words. Let's talk about the energy that we might see throughout the whole actual year.
So this stuff is not matter. This is not like substances. This is pure energy in the types.
Right, because they have to interact. So mechanical energy is what we call the sum of kinetic and potential energy in a system. Now, if you see how this is written, just for
Mechanical energy.
Yep.
A mechanical machine.
Before you write this down, you see how that goes into thermal? Ready? Watch what happens.
Rotate it.
You might want to write it like that.
Yep.
So you might want to see it first and write it second.
Yep.
Okay, next.
Thermal energy.
Or that has to do with heat, usually due to the atoms moving around.
For sure.
Kinetic energy.
Yeah, so internal energy, keyword I heard, heat.
Heat. Thermals, you wear them to stay warm.
Yeah,
Thermal energy makes atoms move.
we're giving you the big one much.
Electromagnetic energy, light and magnetism. If you study physics, like this is a huge part of physics, but in chemistry, we really only focus on the light part of things. But electromagnetic energy is energy that can be reflected or emitted from objects. So a glowing light bulb, okay, the heat coming off of the radiator that you don't see it, but you feel it. These are electrical or magnetic waves traveling through space. They don't need a media to propagate through. It's really cool stuff. X-rays, microwaves, gamma radiation. These are a type of energy that is not actually physically tangible, and it falls under the electromagnetic spectrum.
Yeah, especially gamma. We'll get to that in the last unit.
Yeah.
All right, these last two are pretty quick because these are technically review. So kinetic energy is just the energy of motion.
Connection. Thermal energy causes kinetic motion.
We will redefine what you think these things actually are later.
Yes.
Heat, temperature.
Sorry,
we will do that.
I couldn't help myself.
It's okay. It's okay. And then potential quick, I'll just take care of that one too, because that's just the energy of position or stored energy.
Right.
And so for us, it's generally stored in chemical bonds. We're
Right.
going to talk about chemical stored energy a lot, but in physics, it's energy of position, like lower potential energy, higher potential energy.
And in particle diagrams, like if it's a solid, it's got a lot of energy stored up in it. It's not moving around, so it has high potential energy. If it's a gas, it's all in kinetic motion, so it doesn't have much potential energy, but it's got a lot of kinetic energy. Kinetic and potential are inversely related.
Sure.
As one goes up, the other drops.
Right, and then we're going to learn something called entropy.
Yeah. So.
And in the meantime,
That's all, folks. I click the button and I turn off recording. Yeah.